this is going to be a lesson on gearing and gears. I would suggest that you go back to the page labelled Simple Mechanisms, and on that page, apart from levers, down the bottom there's actually an introduction to gears, simple gears and compound gears. But for this lesson we're going to be discussing, tie's not straight, we're going to be discussing how to work out our mechanical advantage or velocity ratio. We're going to, I think for most of the questions, we're going to be assuming 100% efficiency. So we're looking at mechanical advantage. So what I'm going to do is I'm going to quickly put up on the board a few examples, and hopefully by the end of this we will be absolute ninjas at this gearing stuff. Okay, so gears. You probably use them on your bike. You know, on your bike, if you want to go really fast, you pick the big one at the front and the small one at the back, and that gives you a high gear ratio. If you want to go up a hill, small at the front, large at the back. So you've already had experience with gears. So we're going to write a little bit of information up here. The mechanical advantage, MA, of a gear system, and this is a simple system, is the ratio of the driven gear divided by the drive gear. So that's the first thing you need to understand. What is driven, what is drive? So the drive one is the one with the motor attached to it that's pushing the other one around, okay? And the driven one's the one that's being propelled by the one that's connected to the engine. So let's look at a really simple example of a gear system. Say we had, and I'm not going to count the teeth on this gear, I'm just going to write how many teeth it has on it. Say we had a 10 tooth drive gear, and it's moving in the direction of the arrow that I'm drawing on the gear, and I'm going to write above it 10 teeth. Now it's quite often you'll see that just written as 10 with a capital T, indicating the number of teeth, and it is going to be driving another gear that is bigger. And these gears meshed with each other, and so this gear is actually going to spin in the opposite direction. So when you have a pair of gears, the drive gear is going to make the driven gear spin in the opposite direction. And for this one here, we're going to say it has 20 teeth. And you might see that written as 20 teeth. You might see that written as 20T on there. So you want to work out the mechanical advantage. As per what's written here, you would actually just write MA is equal to, this is the drive gear, or drive or driver gear. It's the one that's doing the pushing, and this one is the driven. So it's driven over drive, so we just say MA equals 20 over 10, and that gives us a mechanical advantage of 2, okay? So it's going to magnify the force, okay, by 2. And seeing the same amount of work is being done, obviously it's over a greater distance. So that's how we work out our mechanical advantage. That would also be a velocity ratio. because we're essentially dealing with distances when we deal with number of teeth. Now, I've written a little note in my notes here, and that note is that you could also use ratios of radii for both of the gears, or circumferences, or diameters. But as long as you're using that rule, driven over drive, okay? So that's one thing that we need to learn about gear systems. Another thing that is of benefit to understand is in a simple gear system, what we're dealing with is what's known as a gear chain. So if you have more than two in a simple system, you've got what's known as a gear chain, okay, a chain of gears. So if I have the same system here, okay, as the system we've got here, and we've got a 10-tooth gear that's the driver, but we want our driven gear to spin in the same direction, we can use what's known as a gear chain with an idler gear. And it's quite a strange situation, but the idler gear, it doesn't matter what size it is. We could make this, if this is 10 teeth, we could make that 5 teeth. And then if we make our driven gear like in the first example, 20 teeth, our mechanical advantage is still going to be driven over drive. This is the driven gear, the one that's being pushed by the motor, and this is the drive, okay? Or driver, we can say drive or driver, okay? It's attached to motor, okay? It's what's making the effort, okay? If we're thinking about a simple mechanism. So we still get MA equals 20 over 10. The size of this gear doesn't matter. You can make it large, you can make it small. It will not change the mechanical advantage. All it will change is this one's spinning this way, which of course is going to drive this one this way. So these two are going to be spinning in the same direction. And this gear here is called an idler gear, okay? And we know that there's a little note down here. We're going to say idler gear size does not matter. Okay, so we use our idler gear in our gear train, and this whole thing here is called, so we can say a series, we're running off the board, a series of gears is called a gear train. Because like a train, they're just attached to each other, and it's a series of simple. It's a series of gears. It's called a gear train, and it's a simple arrangement of gears. Okay, so it's a simple system, not a compound system, which we talk about in our next example. So what I suggest you do is you pause the video and you just get that information down. So we now know about gears, simple system of gears. We now know about a gear train. We've learned some new terminology. We know what an idler gear is. We know that the idler gear does not matter size-wise. Obviously, if it's too small mechanically, there's issues, but it can be large, it can be small, and it's a way of reversing the direction of the driven gear. Okay, so lots of new stuff that we've learnt. I will now be talking about one more thing on this side of the board. So pause and write that all down. And we're going to talk about another way of reversing a gear. So we've got one way of reversing the gear so that it spins in the same direction as the drive gear, is using an idler gear in the center, which is what we did over here. You can see what happens with the directions. If you want to reverse the direction, you can also use a belt or a chain and sprocket. And a sprocket is just a special type of gear that's designed to fit a chain, like on your bike, okay, like on a racing bike or a normal bicycle. So I'm going to write up here. You can also use a chain and sprocket to reverse the driven gear. So if I have a chain going around here, and this is spinning in this direction, you can see that the chain, because the chain will be going in that direction and that direction as per the arrows, so the driven gear will spin in the same direction. So if we had 10 teeth, 20 teeth, this is drive, and this is driven, mechanical advantage is still going to be 20 over 10, which equals 2. So it's the same as our first example, but it's going to spin in the same direction. That's the only difference. And instead of a sprocket, you could have a pulley with a belt on it, and that would be the same. Same situation. So hopefully now we've got an understanding of simple gear systems, what a gear train is, what an idler gear is, and how to work out the velocity ratio or mechanical advantage, if we're talking about 100% efficiency, of this type of gear system. Take your notes. Like I said, visit the simple mechanisms page on Exchange down the bottom, where we've got an explanation of gears and you can actually see them working, and also we have an explanation of a compound gear, which is we're going to talk about in the next video. See you in the next video.